Hi, my name is Ramsey Selim, and as you can see, there was a bit of a technical issue there. There's a bit of a delay line between launching the presentation on the webinar and it going live. So this is the first webinar, and it's one in multiple series. So hopefully in the next ones, the technical problems will have been kind of ironed out there. So this series is the first for Europractice, and it's about advanced packaging, and especially we'll be looking at stepping into the world of advanced photonics for this episode today. With me is Francesco Floris.
Hey, hi Ramsey, hi everybody.
Introduce yourself, Francesco.
Yeah, my name is Francesco Floris, and I'm working in the Photonics packaging group, Tyndall National Institute in Cork, Ireland. And I'm now in charge of the research in the group, and I'm starting this new adventure, taking care of the trainings and teaching programs for Europractice.
Very exciting. Yeah, so today the presentation or the webinar, it's one presentation, but two talks. So first there'll be a talk about stepping into the world of advanced photonics, looking at what that entails. How do you go to a prototype from a device? What does a device in a package look like? Why do you want photonics packaging? And in the second part, Francesco will be talking about giving us examples of what you can expect in future webinars in terms of going into the detail of how to do specific things in photonics packaging, but also some of the training programs, and we'll touch on what will be happening in 2020 in terms of training programs and future webinars. At the end, there'll be a Q&A session. So the Q&A session, if you have questions, just fire emails to europractice.gateway@tyndall.ie. So it's at the bottom of the slide, so you can see it there at the bottom there, and we'll collect the questions and answer them in a Q&A session at the end. But yeah, so let's step into the world of advanced photonics packaging, and yeah, so if you do a Google or go online and do a search online for advanced photonics packaging, there's so much information in there. You'll find books on the topic, you'll find tools and machines that will do photonics packaging, you'll find devices, you'll find plug and play prototypes. So there's a lot there, but maybe what is lacking is at the moment some sort of structured approach to help people understand how do they take their chip design and bring it right through to a prototype where they can test something out. And then why is this little photonics package, why is it important? Why is that something that I should think about when I'm making my design or I'm trying to figure out how to bring my prototype or product to the market? Well, really, photonics packaging is in the heart of photonics. So photonics, for the last 25 years, has been such a disruptive, innovative technology. It's transformed and is continuing to transform the medical sector, where people used to have to travel long distances to get to hospitals or medical centers where they'd get certain diagnosis done, whereas now you can get certain machines that will use photonics packaging at the heart of it to have handheld devices, and these handheld devices can go to the patient in their home, get the test done, and the medical expert has the results straight away. So there's an impact in the medical sector, and that's very evident and is growing at the moment. There's also the Internet of Things and 5G datacomms and telecoms, where photonics again is at the heart of the revolution in there. So automated vehicles are using photonics and by default using photonics packaging to enable the revolution in automated vehicles. Looking at how the Web 2.0 is got that increased demand from the user for more data, more capacity, and that is translating into photonics solving that problem for people. So there is more capability for machines to talk to machines, people to upload more data, load up their YouTubes, their Instagrams, their Facebooks, etc. But also other sectors. The security and safety sector, for example, drones are playing a big role now, and photonics accessories are so much now, they're just so prevalent for drones. Where in Italy, there's a lot of seismic activity, and what they're doing now is, for safety and security, they send out drones with LiDARs on them to find or to map areas and to find other survivors. Where should responders go to? Where can they find, so they can find people intelligently and safely. Also, they're getting used, drones, in agricultural technology revolution, where photonics is there again at the heart of it. So spectrometers are attached to drones, and they're sent out to, again, map and find out, get more information from the fields and the arable land, what insects are there, what pesticide levels are there, get an idea of the substances that are in the air and on the plants, and all that information now is coming back to farmers, and they're able to use that information to feed back into their agricultural process. Other aspects as well that are not on here on the slide, but you can think about very easily, is VR, augmented reality. So photonics is at the heart of that change and that innovation. So how do you get your chip to become a prototype? And how do you get your chip to become a photonic package that can be plugged into your prototype or your product, and you can then try it out and test it out? Well, at the beginning, you get your chip, and your chip is this, it's got all your IP in it, and it's got your clever designs in there, and how you're going to manipulate the signal. And but then when you first get it, the first thing you'll probably do is, what I would do at least, is I'd do a visual inspection, check it out. I'd probably take it under the microscope, have a closer look, check out the design that I've done. But the next thing we want to do is now evaluate its performance. Is it going to do what we're expecting it to do? And there's a couple of ways of doing that. One, I can plug it into my prototype or my product, but I need some sort of photonics packaging to be able to plug it in. I can't just take the die and put it into the prototype. Or I need to set up something on a workbench, bring a laser, bring some fiber, or put a detector there to pick up the signal. So you're trying to align now your laser to your chip. It does the processing of the signal, and now you need to extract that information, and you need the photodetector to extract the information from the chip. And this can be done in an experimental lab, but then you have to focus on and think about, are you aligning it to the best possible position? Are your probes down correctly? Are you getting the right information from your chip, or is the experiment compromised because of an alignment that you may have there? Whereas photonics packaging, you've got experts that are putting these things together, and it's fixed in position, so every time you repeat the experiment, it always works. It's the same repeatable result. But then also, you can also just take that photonics package and plug it into your product or plug it into your prototype, and you're able to test your prototype straight away. So that's the idea of a chip to a package. But how does that chip become a photonic package? Well, the first thing you want to think about is, well, you've got a housing or a base plate. You're going to put everything onto something or into something, and you need to think about the constraints of that. Is it going to be a pluggable? What does that need to plug into? So what's the mechanical criteria for it? Are there thermal implications to it? Will it do some passive cooling, so you've got some air coming down below it? Or do you need active cooling or active heating, or active even thermal management, so you're just keeping it at a specific temperature all the time? It could be room temperature, but it could also be higher, 70 degrees, it could be lower. So in that case, you put in a tech now. So a tech would be in place, and this tech, you have to also think about, well, what temperature you want it to run at, what's the power management that you'd want to be doing here to control your performance of your chip. Now, the best thing is, if you've got tech in there, is to try and get your chip as close as possibly on it. So if you've got your pick, then your pick is going directly on that tech to keep that temperature exactly where you want it. The further away it is from the tech, the more power you need in there to control the temperature of the package, and there's more implications there. So now you've got your circuit on the tech, but you need to get light into it and light out of it. You need to read and write and get the light in there. So the next thing somebody would think of in terms of photonics packaging or the assembly process is that the laser is getting placed onto the PIC. So it depends here now on your coupling scheme, but also on your chip. Is it silica? Is it silicon? Is it indium phosphide? Are you using grating couplers, edge couplers? What is it you're using? How are you going to get the light from your laser into the chip? Do you need some more information there do you need kind of a flip chip on there? So these are some constraints and things to think about. But also now that you've got your construction, you need to read and write to the chip. And that would be through having wire bonds coming down to your detectors. So it goes to a PCB and you're reading the information from the detector, which is reading the information from your chip. But also you can be driving your laser. There's also an FEA on there. So you've got your processed signal and you want to either transmit it or you're receiving a signal as well, it could be. And that's going through your FEA. So that's now you get your photonics package. So your PIC doesn't just go by itself into some sort of prototype. It needs an assembly around it to enable it. And once you've got that, then you're able to plug it in, whether it's into your prototype, into your product, on your workbench, but you know that it'll work every time. So just to kind of cover again those key aspects of what you're thinking about when you're putting together a photonics package. The considerations here are, you want to think about your optics. So are you using fiber to get the light in and out of the chip? Are you using a laser to directly onto the chip? Are you using detectors? What kind of electronics is there? When do you use wire bonds? When would you use flip chip? So these are constraints that we'll be talking about in future webinars as well, and giving you detail on when you do use each one and how you look at that. Thermal implications, like we said, do you need a tech? Is it passive cooling? And some of the mechanical implications there as well. So what's your housing look like? What materials are you using? Do you need it to be also hermetically sealed and stuff or not? But let's focus first on the optical side. Start off there. So Francesco, can you maybe tell us a bit more about how I would get my light on off the chip?
Yeah, let's say that it's not just shining light, but it's more, let's say, understanding that you need to shine properly the light into your PIC. The photonic integrated circuit, as you said, is like your processor. So you use it to solve problems. And this means that you need not just to shine light on something, but you need to couple properly the light, which means that, for example, you have a light pulse with many electromagnetic parameters, and you want to take care of all those parameters that are important for you because you are putting some real important information in that specific parameter. So in this case, what we want to start doing is to offer training programs, which means that we are taking care of, for example, let's talk about, as you said, light coupling schemes. So it's not just to put something on top of something else. So in this case, for example, light coupling schemes can be, let's use a fiber. The fiber can be, the vertical fiber is the easiest way to couple light into a system. And let's say that we want to use the grating coupler, because we want to have a fixed phase. So the grating coupler can help us in taking care of the phase. But the problem is that vertical fiber, it's easy, but from the mechanical point of view, it's not good. So we can switch, for example, to the plane or horizontal fiber. That is better. But the problem is that the beam shape is a little bit different. And what happens if, as you said before, we are using a drone? We can't have a long wire always connected to the drone. So we need, for example, light sources and detectors hybridly integrated on our PIC. And it means, for example, that we can resort to the so-called micro-optical bench. So you will use lenses and prism in order to collect and bend the light and shine the light on top of the grating coupler. But this process must be done properly. And again, for example, the beam profile is changing. Let's see, for example, in this case, the mode field diameter. If I have an horizontal fiber or a vertical fiber, I have a mode field diameter that is of the order of 10.4 microns. and it's okay for the grating couplers. But if I look at the mode field diameter that comes out of a laser, it's too small for microns.
Yeah.
So the question is, how can I use properly the photonic packaging rules, procedures, the knowledge that I can acquire from studying all these packaging rules and procedures in order to manage, is not just manipulate, it's the fact that you really want to manage the light. In this case, if you properly, let's say, tune your micro-optical bench, you can see on the right, obtain again a mode field diameter that is around 10 microns. And this means that you are again able to couple in the best way your light into your grating coupler. Yeah. So you can use your peak to solve your problem.
Right.
Because it's not just light, it's exactly the light that you need. So in this case, we want to change a little bit the approach, the point of view. So from devices to prototypes, there is not only just one how error, which means that we are improving the materials, we are improving the schemes, the techniques, but we want also to improve the skills of the people working in photonics. We want the people to be always more and more trained, which means that they can solve more general problems. So if you see that you need something with a different thermal properties, a material with a different thermal properties, what you can do is you can look for that. So you can change the material, and you know that it's working. Why? Because you know that you have to take care of the thermal, but in addition, density, strain, everything that can then affect the final result in your package, which means reliabilities, which means it's working properly, which means that you are getting out from the peak exactly what you want, what you think. So our idea is to, let's say, help the education and training world to move a little bit more forward, going to the, let's say, small and medium enterprise direction. So it's something like we want to help the people to have knowledge that can be immediately useful in the real world.
Right, so it's applied straight.
Exactly. We want people to be able to put their hands and fingers in order to solve problems, not just gluing stuff.
Okay.
Yes. So in this case, the first idea is let's start working at the academia level. So let's start to bridge the gap between the academia and the small and medium enterprises. So let's help the students to learn practical things that are useful when they immediately after that they get the degree, they jump into the world of working in small and medium enterprises. And we can't forget the people that are already working.
So already necessary.
Exactly.
Right, yeah.
So in this case, we want, in addition, let's say, take care of them, which means that we want to start providing them specific trainings in order to give them all the support that they need, which means that you have to take care of the time required. So small in terms of time, super focused trainings, 2-3 days, and then the people can come back to work, but with improved skills, so they can see immediately
the effects.
Right,
yes.
This is the idea. So we want to take care of both the realities, people that are studying and people that are already working. And we want to give support 360 degrees, which means that we want to give them the support from the more, let's say, theoretical point of view, modeling or optimization, or why not, testing. How can I properly analyze the data? Am I sure that I'm measuring exactly what I think that I am measuring?
Yeah.
We can provide them all the skills that are necessary to be sure that they are really effective every day in their job place.
Right, yeah.
So In these regards, we have in mind mainly, let's say, 3 different types of activities. The first one, as I said, are training courses on hot topics. 1, 2, 3 days on specific topics. And the first should start in April next year, April 2020. Then the second activity is a 1-week summer school.
Okay.
July 2020. So you see something longer. So it can be a different type of, let's say, like a place where you can meet the people that are already working, for example, in academia, or the people that are already working in small and medium enterprises. We want to create like a point where the people can meet, talk, and understand each other, helping each other to grow.
Okay.
And then obviously the webinar series, and you introduce them to the people. So.
Oh, yeah. So yeah, I'll kind of touch on the point of the webinars here. That's very interesting. So you're in terms of training and upskilling people. So you're saying there'll be some training courses next year and a summer school, and then we'll do some webinars as well, series where we'll be going to detail or more detail about the key things in photonics. Photonics packaging, but also packaging itself, advanced packaging, system integration, all that good stuff. So yeah, like I was saying at the beginning of this presentation, this is a stepping into this world. So it's an introductory webinar just to give you a feel of what you'll get or see next year, so in 2020. So we're expecting to have here now, the plan is every 2 months to have a webinar series and a webinar session in the series to look at things like Francesco mentioned here, the design of the photonics package. What aspects do you have to think of in detail? Take case studies. When should you use wire bonding? When should you use flip chip? Which coupling scheme should you be using for your technology? And looking at things of best practices for thermal management. We'll be also kind of interviewing some of the technology leaders, looking at equipment. So there's quite a lot of exciting stuff there going on for the next few webinars that are coming up in 2020. What I would say is the best way to stay connected and to know about what we'll be presenting is to follow us on Europractice on LinkedIn. So follow Europractice on LinkedIn and you'll be able to hear what's coming next and know about the webinars. You'll also be able to kind of put in your suggestions of what you would like to hear about as well. So these are a few of the ideas that we're currently working on to bring to you in February and then kind of kick that off in 2020. But yeah, so it's kind of a Q&A session now. So if you email your questions through to europractice.gateway@tyndall.ie, we can then try to answer some of your questions. But yeah, so that's quite an interesting talk there about your training sessions. So what kind of hot topics have you got in mind?
Well, for sure, it's quite an interesting topic in, let's say, see, for example, the coupling schemes. That is the example that I showed you before.
Okay. Yes.
Mainly because it's the it's exactly the point where you are shining the light in, and what happens is that you are interfacing the external world with your peak. So you have to pay attention, and not only in terms, as I said, of coupling efficiency, which means the power that I am maybe losing, but also the fact because different coupling schemes can give you the solution to different problems. And obviously the design of the chip is quite different. So if you consider grating couplers, for example, is different with respect to working with edge coupling. Edge coupling, for example, is great for hot plug connections. And can be used, for example, if you need to get direct access to your peak, but you do not have, for example, constraints in terms of phase, or, for example, in terms of conservation of some electromagnetic parameters, while the grating coupler, since it's a more complex scattering object, you need to pay attention to many other features Obviously, for example, the grating coupler is good if you want to use it in addition. It has a filter, so you can filter the light. So if you have a broadband source with a shape that is not, for example, exactly what you need, I don't know, I'm imagining a Gaussian shape, you can use the grating coupler to filter the light and change the shape. So it can be, for example, good if you need a perfectly Gaussian beam inside your waveguide.
Right. We've got another question coming in here, and it's about the summer school. What's happening in summer school then?
Well, okay. In summer school, the main idea is we want to create a place where people comes from different, let's say, I don't know, small and medium enterprises, or for example, PhD students, and can stay together, talk together. And I'm thinking in particular, I think that we should really start to create a link between academia and enterprises. So what is important, for example, is that people that are working in enterprises start talking to academia, telling to the academia what they need.
Right, yeah. Okay, thank you
because
very
it
much.
Seems that these are two separate words.
Thank you very much. So I'm seeing here some comments from people that some people are managing to see view the webinar fine. Others are having problems. I see some people are able to see and hear the webinar fine. Others can't hear it very well. And some others, the link is not working for them. So there's a range here of technical issues for various people. What I'll do is we'll make this available for you so that you're able to download it later on or listen to it later on, and maybe that's the better way to do that at the moment. So I'm not entirely sure what's happening there in the technical problem, because some people are viewing it and they're sending through some questions here, others can't quite. So sorry about that, but hopefully we'll have that teething problem out of the way for the next webinar. Thank you very much for tuning in, and like I say, we'll make this webinar available for you to download and watch at your ease. Also, if you have follow-up questions later on because of the technical problem, please feel free to drop us a line at europractice.gateway@tyndall.ie. Thank you very much.
Bye.
Bye.